presenting the codes and installation. And this announces Thirsty Thursday, episode 37, which is actually kind of cool. And with that, I'm going to stop sharing my screen. And if I can do this right, Matt, I'm sorry, let me get this and move this and change the presenter. And I'm going to say, Matt, welcome to the team. You are now the official presenter.
Thanks for having me, Steve, Ted, and Jason. It was good to meet all of you guys. I'm looking forward to it. So let me share my screen here.
Wow, that's a big pipe you have there, Matt.
Can you guys see, which screen are you guys seeing here?
That's,
right now,
that's free. That's polypropylene, isn't it?
Yeah, that's an electric fusion system.
Yeah,
Can you guys see the?
No, so if you go to the pull down arrow under the play button, you can scroll down, and as long as you have the presentation up somewhere, you can go to PowerPoint presentation. It's about the third or fourth thing down. Right now, we see the design portion of PowerPoint, so we can see the first 4 slides in your presentation, which looks pretty cool because it looks like I'm looking down the center of a spiral staircase, and I'm about to die falling down to the center.
Okay, so let me try something here.
Looks like vortex.
Yeah. Okay, let's see. Screen.
So as everybody can tell who's on this presentation, we're all working remote this week. Ted and Jason are in different parts of the world. Ted's on his way in Massachusetts. Jason's in Vermont. I'm nowhere near any of the above. And again, Matt, we're not in presentation mode. There we go. You got it. Woo!
You got it right there.
Perfect.
Bingo. We got it finally.
Perfect.
Excellent.
Okay, guys, let me get started. Okay, so the topic tonight is going to be, certified flue gas venting systems. We're going to be specifically focusing on UL 1738. If you're not familiar with myself, I'll give you a little bit of background. I'm the flue gas venting market development specialist with IPEX. I've been with IPEX for almost 5 years now. First couple of years were as an application engineer, so supporting our sales team, working with design engineers, helping write specifications, and training installers on our industrial and mechanical systems. And then the last couple of years have been focused on venting. So again, thank you for having me. So to start off, if you guys aren't familiar with IPEX, we are thermoplastics piping manufacturer. So we manufacture thermoplastic piping systems for a pretty wide variety of applications. These are a few here. So, ranging from municipal C900, C909, as well as irrigation pipe to electrical conduit, telecommunication. We get into industrial piping systems. So, corrosive waste for, underground piping, double containment, lab waste, high purity piping, and then of course, mechanical and plumbing. So venting for, gas-fired appliances, which is what we're gonna be talking about, hot and cold water, drainage. And I'll use PVC as an example. PVC, because it's a common material, it gets used in, virtually all of these applications, but, you wouldn't use an electrical conduit pipe in an industrial application because, the electrical conduit pipe is made to an electrical conduit standard and the industrial pipe is made to an industrial standard. So that's the idea, same thing applies to flue gas venting. That's the idea behind the presentation. You want to be, in these life safety applications, you want to be using a product that is actually made to a venting standard. So that's the basics of the presentation. We're going to start off very broad. I'm sure a lot of you are going to already be familiar with some of this stuff, and hopefully you learn something as well along the way. But we'll start off broad on what is venting, just so we're all clear on what the application we're actually talking about is. We'll look at what products have been used in the past, kind of why and where we're going in terms of what the market's doing. We'll get into the product standards, kind of compare those a little bit to UL 1738, some of the model code updates, and then we'll get into some design considerations, best practices for installation, And then we'll wrap it up with an overview of the products from IPEX. So I'm sure you guys will have questions, but I will save time at the end for anybody that does. So just so we're all on the same page, don't worry about the equation there, but essentially we're talking about gas-fired appliances. So these are going to be, typically burning propane or natural gas. When you burn these fuel sources, you end up with carbon monoxide and some water vapor. The carbon monoxide usually reacts again, and you get carbon dioxide as a mixture. And the purpose of the venting system is to safely vent carbon monoxide and carbon dioxide and the water vapor, which is usually condensate, to the outside of the building, because these are dangerous and they need to be vented safely. So that's the purpose of the venting system in a nutshell. These gas-powered appliances are divided into 4 venting categories, and they're broken down to based on whether they are condensing or non-condensing, and whether they are negative pressure or positive pressure. So the categories are 1, 2, 3, and 4, nice and simple. So I'm going to be focusing mainly on plastic venting. That's kind of where we're focusing. So those are going to be mainly category 2 and 4. So where you have, and these are your condensing appliances, where typically in condensing appliances, you're going to have lower flue temperatures where plastics are suitable. Once you start getting into the category 1 or 3 non-condensing appliances, typically the flue temperatures are too high for plastic, so you don't really see too much of that application if you're dealing with plastic venting. So these category 2 and 4 appliances, these are going to be your high efficiency boilers. These are going to be your tankless water heaters. These are going to be tank type water heaters and high efficiency furnaces. So that's the application, which is high efficiency is where everything's going these days. So right now, yeah, depending on where you're located, depending on where you work, the market could definitely be in a period of transition right now. And up till now, and in some places where the code hasn't changed yet, when you install one of these appliances, you would look inside the installation manual, and there's going to be a venting section. In the venting section, you have approved materials, like you see on the screen here as an example. And you'll see approved materials, and then under these approved materials, you're going to see different standards. When these installation manuals were written, whenever they were years ago, no one manufactured PVC or CPVC or polypropylene or any other plastic specifically for venting. It just wasn't done. So when these manuals were being written, they needed standards for each of these materials. They couldn't just list PVC and not have a specified standard associated with that. So the standards that were written in were plumbing standards, and the reason for that is because they're cost effective, they're readily available, people are familiar with them, and there really wasn't a better alternative. These were the best products available for this application in terms of thermoplastics. So basically, due to lack of availability of anything other else, this is what you end up with. And they worked well for many years, but there were some issues, and the issues kind of started when mainly design engineers or inspectors began asking the plastic manufacturers for letters, basically asking if their product, could you provide a letter saying that your product can be used for this venting application? And across the board, they all said no. And the reason for that, not that they were trying to be difficult, but mainly because the plumbing standards that they're manufactured to have no relation really to flue gas venting or that kind of application. They've never done any kind of testing associated with that application. They didn't know how the product would perform, so they weren't able to provide those letters. You wouldn't, as an example, in using other products, we wouldn't be able to provide a letter saying electrical conduit pipe could be used in an industrial application, right? Same kind of thing. You don't know how the product's going to perform in that application if you've never tested it. So there was a bit of risk and liability, especially for installers. If something failed, who's going to be on the hook now? And that's where you start to see people asking questions, and then slowly you start to see the market move. So let's look at the codes a little bit more quickly, but I'll let anybody jump in if they have questions. Okay, so
no questions. No questions here, Matt. Sorry.
No problem. No problem. So looking at the standards, these are the ASTM plumbing standards that are very commonly referenced in these installation manuals, again, because there really wasn't an alternative at the time when these products were written in. I'm pointing out 3 here. So the first 2 are ASTM D2665, and which is your standard for PVC drainage, waste, and vent. And then you have your second, which is ASTM D1785, PVC Schedule 4080 120, and then the equivalent, the third one there for CPVC is going to be ASTM F441. So these standards have been around for a long time. They've been used very successfully for plumbing applications for a long time. They're well-written standards, but they were intended for fluid handling applications. So, drainage, waste, and vent water applications. They weren't really designed, and they don't really have any testing associated with them for venting combustion gas. When a venting system, and we'll get into the application a little bit more, but the venting system experiences heat cycling, which is one of the main issues with the longevity of a lot of the plumbing pipe. So again, these standards were all intended for fluid handling applications. And each of these standards has a technical committee that updates the standards, very similar to how a city's building code has a committee to make sure that the standard is interpreted properly or the code's interpreted properly, that kind of thing. When these technical committees realized that their standards were being used in an application where they weren't really intended, they added a note. So these notes were added in, I believe, 2018. So not very long ago, which is why I say, this is kind of a fluid market kind of thing. So this is the note here, and this is from ASTM D1785. So this is your Schedule 4080 120. This is taken directly from the standard. So I just highlighted the last sentence there, but I'll read it out if anybody doesn't have their screen available. What it says is, this standard specifies dimensional performance test requirements for plumbing and fluid handling applications only. It does not include provisions for the use of these products for venting combustion gases. UL 1738 is a standard that does include specific testing and marking requirements for flue gas venting products, including PVC. So, right in these standards, there's this note which basically says, again, the standard doesn't have any testing requirements for venting combustion gas, and it refers to UL 1738. So again, a bit more of a liability issue for these products if something fails. There are also 2 model codes. So I'm throwing a lot of codes and standards at you right now, but I promise it's almost done. So there are 2 model codes in the United States that the fuel gas codes are written after and modeled after. So there's the NFPA 54, which is the National Fuel Gas Code, and there is the IFGC, which is the International Fuel Gas Code. So on venting, they say identical things. So it doesn't really matter which state uses what to model their code after. They say the same thing for this. So basically, in 2018, they updated the plastic piping, plastic vent joints, and special gas vent sections. And what it did for plastic piping and plastic vent joints is it added UL 1738 as an option. So what it said is the appliance manufacturer is still going to make sure that their appliance is certified for use with whatever venting material they choose. And then once that appliance is certified with that material, that material and the vent that's used can either be manufactured to the standards they list in their appliance manual, or it can be listed and labeled in accordance with UL 1738. So it gives installers the options. Now, some states and jurisdictions have taken it upon themselves to only allow UL 1738, and then there's a whole bunch that still allow the choice. So it really depends on the jurisdiction that you're working in. And it can be kind of confusing if you're working in multiple jurisdictions who require different things.
Matt, may I ask you a question?
Sure.
Germane to what you're saying. Has the liability of using a pipe that's not UL 1738, for instance, plumbing PVC, has the liability of using that been tested?
So when we
the legal liability of using
the legal I don't know about any I don't know about anybody like legal suits or anything like that. I know that if a plumbing pipe fails, the PVC manufacturer, basically their warranty is voided. So it would be either up to the installer or I guess the appliance manufacturer. I'm not sure. I guess everybody would be sucked into that at that point.
So Matt, so on top of that, so did you explain what 1738 actually says? Did I miss
I'm
that?
gonna get in. Nope, I'm
You're
gonna
gonna
get into that.
Okay, good. So next thing, and so you know that when it comes to venting products failing and legalities in the US, I can't speak for Canada, right? But I can speak for the US. And in every application I've seen where it's gone to court where either people have been injured or hurt or worse yet, killed, it always came down to the installer and to the building inspector. So, and when you went back to PVC, but them writing out the fact that they're not 1738, don't use for a venting product, that has come and gone over the last 20 years in my life. I've seen that show up, not show up, show up, not show up, come and go. And it all depends on how much PVC they want to sell. But it seems like every time there's a lawsuit, I see them all of a sudden write it into their specifications. So could just be a coincidence, right, Ted? Just a coincidence.
Well, that was the whole reason I asked, because people are going to ask, why should I use this now when I've been using PVC, white PVC for plumbing, like Schedule 40 for years? And so the question I think becomes really, particularly in the United States, which is a litigious society, are you going to be held responsible if there's a failure and you're using a product that's not rated for the application?
Yeah, no, that's a great point, guys.
That was, so I would say, I mean, personally, this is a very good justification for using 1738.
Yeah, I'd have to agree with you, and I'm definitely not as up to date on any kind of legal cases that have happened. But in a few slides, I'm going to go through the 1738 standard and highlight one test that I think is good for everybody to know. And I can get into detail more if you guys have more questions about the testing, but there's a couple that I wanted to highlight that I think will be interesting for everybody. So the other thing that I wanted to highlight just quickly on these model codes is the last part here, which is a special gas vent, which has caused caused a lot of discussion in certain jurisdictions and none at all in others. The model codes say that special gas vents shall be listed and labeled in accordance with UL 1738, so it doesn't give an option. Now, the jury is out on what the definition of a special gas vent is. It means different things in different jurisdictions. I'll give you an example, which might not apply to this group as much, but just an example. In Alabama, they consider a special gas vent any category 2, 3, or 4 venting system. And when this model code came into effect, they used that to enforce UL 1738 over a big portion of the state. In other areas, special gas vent is a completely different thing, but just kind of interesting to note there that the code is obviously interpreted different ways, and I'm sure everybody has seen that. The International Fuel Gas Code says the exact same thing, so I'm not going to go over that, but just to let you know. So this is kind of basically a flow chart to kind of say, what does the code say when we refer to venting? So starting off, what does the code say? Well, it's either going to specify you use UL 1738, or it's going to refer to the appliance manufacturer. In many cases, it does refer to the appliance manufacturer. In the installation manual, the appliance manufacturer is either going to list UL 1738 or it's going to list ASTM standards, most likely both. I know NTI Boilers list both. If you look at the ASTM standards that we just talked about, in those notes, it says do not use for venting combustion gas, and it refers to UL 1738. So, it is a safer product. is a more durable product, which we'll talk about. It reduces your risk of failure. And you know, it is kind of lets you sleep a little bit easier at night, knowing that the product is actually tested in that application. And again, we'll get into some of the key tests here. So this is something that I wanted to highlight. So this is an appliance standard for a chart that's taken from the appliance standards specifically for water heaters, but it's just an example. And this is causing, it does cause some confusion. And I'd, you know, if anybody wants to chime in, I'm sure that someone might. But what this chart says as a title is maximum allowable temperatures of typical non-metallic vent materials used in water heaters. Like I mentioned, is taken from the water heater standard. On the left side, you have, or left column, you have PVC, different materials, CPVC, ABS. And then in the second column, you have heat deflection temperature, and then you have some standards. So specifically, heat deflection temperature is the temperature of a material. So when you're referring to, you know, these plastics where the heat deflection temperature is the temperature where the material begins to fail under a specific load. So there's a specific test that you do to determine the heat deflection temperature, and that's the temperature where it essentially fails under a given load. But because of the title of this chart, it says maximum allowable temperatures, very often you see PVC or CPVC used right up to the heat deflection temperature, when in reality, if you ask a PVC manufacturer or a CPVC manufacturer what the temperature rating of their PVC plumbing pipe is, it's going to be 140 degrees. So that 18-degree difference is, you know, referred to as a safety factor, which is typically built into the product. But this chart does, you know, depending on how you look at it, it can, you know, can allow these products to be used right up until their heat deflection temperature. So you have these products that aren't tested for the application as well as they should be, and then they're used above the temperature which they're really intended to. So, which is, you know, kind of how we get into the UL 1738 standard. It has the safety factor built into the standard, and it tests for some of these elevated temperatures. So, kind of how you eliminate some of the issues with the certified product.
Well, let me ask you this: in any of these cases, regardless of the temperature and the deflection, were they tested with the corrosiveness of condensate, or are they typically just for just water fluid handling?
That is a great question. The ASTM standards don't have any corrosive testing. The UL 1738 does. I'm going to mention that in a few slides. But that is one of the key tests that we typically highlight, along with, you know, elevated temperature testing, low temperature testing, and then heat cycling. But that's a great question, Ted. So yeah, up till now, there's kind of been a disconnect between what's specified by a lot of the manufacturers and then the vent manufacturers themselves. So the solution is you know, simple. I don't know if that's the best word, but what UL 1738 does, it allows the appliance manufacturers to continue specifying their preferred venting materials. So if you manufacture an appliance and you only want to allow CPVC or polypropylene, or only allow, you know, aluminum or stainless steel, it still allows the freedom to choose whatever material you want, because all of these materials can be certified under the one standard. So there are provisions in UL 1738 for each of these materials, and each of these materials, you know, there's different testing temperatures based on what you want to rate your material to. So it gives the flexibility for that. So it doesn't limit your material choice, but what it does is replaces the plumbing products, which were not really intended for the application. And the reason I say it replaces them is because when IPEX did testing for System 1738, we tested plumbing products, our own plumbing products as well, and they were nowhere near passing some of the tests. So which is why it took us quite a few years to actually come up with a product that could meet it, because it is a very difficult standard. So when I say that, you know, it's not just some people will look at the black PVC and say, you know, it's just colored different. It's really not, and you can do the testing to see. But when you're certified to this standard, it is definitely a qualified product. And again, eliminate some of that disorganization and confusion, kind of we talked about before. So let's look at some venting issues we see, and we'll talk about how 1738 can alleviate or some of these issues. So the first is exceeding flue gas temperature limits, which is a big one that we see here. So this highlights a few problems. One is that these ASTM standards, they don't have elevated temperature testing associated with them. So they set a cell class, and the cell class sets an HDT of 158, and that's essentially it. So as long as you have that heat deflection temperature, there's no additional testing to see if this product can handle elevated temperatures for a short period of time. If an appliance runs hot or it's not maintenance properly for a short period of time, temperatures can rise. The 1738 standard lacks that.
So Matt, you mentioned the time and no maintenance. At what point does that fall into the homeowner's liability instead of the contractors because of the lack of maintenance? I mean, is it our contractor's job to make sure these things are maintained? And what happens if the homeowner doesn't let them in, and now it's 3 years or 4 years down the road, and your stack temperatures go from 150 to 195, which we've seen. And I've seen things, I mean, people might think that left-hand pipe is painted, but I've seen them that color, which is the color it goes before it goes black, and then after black is fire, right? So, and I do that in my venting program, and these guys have also, a lot of people here have seen my Darwin Awards of venting. But this is amazing. At what point does the homeowner have to take some responsibility?
Oh, I agree. It's definitely, and that's not what I am trying to say, that it's all on the installer or the contractor. There is a responsibility of the homeowner, of course, to maintenance everything in their home, and I think a lot of people don't realize that. But it can happen, and when you use a certified product, you have that additional safety factor built in there.
Cool. I have a question. Again, unfortunately, one you probably don't know, Matt, but I can be reasonably sure that none of these plumbing products that are pictured here have any kind of UV protection either. Do you know if the 1738 pipe has any provision for that? Because it's always going to be some section of it that's exposed.
Ted, that is a great question again. Yeah, UL 1738 has a UV light and water test associated. So there are a number of conditioning tests associated with UL 1738, UV light being one of them. I believe it's a 90-day and then another 180-day test. And that's one thing that's difficult, especially in the picture here. It's outside, so you have these elevated temperatures, possibly with UV light. That combination is something that a lot of the plumbing products have difficulty handling, right? So it's not necessarily when you have one thing, maybe a little bit of a high flue temperature. It's when you have that, maybe with condensate, which is corrosive, and then you throw in UV light as well. So the combination of these things, the plumbing pipe's not designed to handle it, right? So you have a lot of, and it might not fail right away, but that's not going to last the lifetime of the appliance, which is the really important thing.
Hopefully it lasts the lifetime of the homeowner.
Yes.
Hopefully the homeowner lasts the lifetime of the pipe. That's the statement, Ted.
Exactly. So yeah,
no,
that's
I apologize. Please don't think I'm asking these questions to be difficult. These are all reasons I think contractors should be thinking seriously about not using PVC.
Yeah, no, and these are great questions. These are good things. No, by all means, keep asking questions. So these are this is the first thing that we see. Elevated temperature, UV light. That combo is pretty rough on the plumbing products. The other, again, environmental conditioning. So we've got it right here: UV light and condensate. Even low temperatures. So plastics especially get brittle at low temperatures. In winter months, it's not uncommon for plastic piping to be left outside. It's very common for a hairline fracture to occur on the end of a pipe if it's dropped and it's not taken care of. The products obviously aren't going to be handled with white gloves. In a plumbing application, if you have a hairline fracture and it gets missed and it's installed, you know, when the system is tested, you can notice a water drip leaking, cut the pipe out and replace it. In a venting application, you're dealing with carbon monoxide, you're dealing with carbon dioxide. Carbon monoxide is extremely toxic, but it's also odorless and tasteless, and there's no color associated with it. So it's very hard to detect. It's much more difficult to detect than a water leak. So you want a product that's going to be more durable, that's going to be more resistant at low temperatures. So part of 1738 is a low temperature test. So it brings the pipe down to -4 degrees Fahrenheit, and there's a series of drop tests to ensure that the pipe is more brittle. Sounds like a simple test, but if you do that with a lot of the plumbing products, they'll fail pretty quickly. So again, the durability of the certified products is kind of something you see here. And then, like you guys mentioned, installation error. So right now with the plumbing products, if an installer has a question about how this venting pipe should be installed in the field, and they call a PVC manufacturer and ask them, how can your plumbing pipe be installed in this venting application? The PVC manufacturer is going to say that product, we don't support the product in that application, and you shouldn't be using it. So they're definitely not going to give you installation instructions for an application they don't support. Now, when you have a certified product, part of UL 1738, the standard actually requires that the product comes with an installation guide. So every box of elbows, when you use, at least with IPEX, every box of elbows comes with a hard copy of the installation guide, and then there's the PDF online that you can reach out to. But it's not so much the actual installation error, it's the product support that is lacking with the plumbing products. So you're not getting job site training, you're not, you don't have a step-by-step process for installing the system, you don't have best practices. What are your requirements if you're terminating through a wall or a roof, or if you have a commercial application with multiple terminations, what are your spacing requirements? These little things that come up that can cause headaches down the road. When you use a certified product, you have that product support.
So Matt,
and then the last.
So Matt, I just zoomed in on that last picture, and if you just go back 1 second, so and I'm looking at the circles and the arrows and the 15 pictures. I mean, let's bring up let's bring up a Christmas special, right? Where we're going to sing along. But in the top right hand, so on the right hand picture, I see a broken elbow. And what product is that? Is that PVC? I mean, it looks like CPVC, but is that? I mean, what is that?
It looks like purple primer on there, so I think it's PVC. It might just be the lighting.
Yeah, I believe it looks like with purple primer to me.
Yeah.
I mean, the PVC. I mean, that PVC or CPVC elbows just busted the hell off.
Yeah, so that could be a number of things. It could be a lack of the proper support. So either the system was installed and it wasn't supported properly, and there was excess force on that elbow, and over time it caused it to break, or an elevated temperature caused it to become brittle, and then you have failure if it's not supported properly. There could be a number of issues. It could be expansion and contraction, but when you look at a certified product, all of these issues are in the installation manual. So
I mean, now you have this is like the Alice's restaurant, which is what I was referring to before, of pictures, right? So we hope that the judge isn't blind like that, but and I see these and I just scratch my head that, wow, that thing just sheared right the hell off, and that takes a hell of a lot. I mean, I've put CPVC Schedule 80 under a lot of tension, and I've never seen it do that in a house. That's unbelievable.
Yeah, some of the pictures are crazy. This is actually some older pictures. I have some good ones that I wish I updated, but yeah, no, you see some crazy pictures that come back. The ones on the left, the top left there, you have the pipe not, all the way into the bottom of the socket, and then, the pipe not cut square on the bottom left. So that you don't cut the pipe square, there's a big reduction in joint strength. But when you go and do job site training, this is something we talk about, little things like this that can make a big difference in the end, right? So you don't know how that joint on the right side there, how it was assembled, could have not been assembled properly, and then you have issues like that. So yeah, all good points. And then the last thing is a lack of product support, kind of touching on what we just mentioned, but things like specialized fittings. So I always give the example of a combustion analysis test, which is required in certain jurisdictions, typically done after the appliance is installed, after the venting system is installed. And how does that person now test the combustion gas if there's nothing part of the appliance, if the appliance doesn't have something to do that? We've seen people just drill into the PVC stack right above the appliance, and then they do their test, and they have to seal that back up. Duct tape or some caulking that you see like this. That's not a long-term solution.
Silver high temperature tape is what we see all the time. I mean, you could tap and put a brass plug in there or a stainless plug, but what we see is the aluminum or aluminum tape that they use on ductwork, peeled, stuck, and right on there.
Yep. Yeah. So the thing is, when you drill into these PVC stacks, it's very easy to cause a hairline fracture, and you might not notice that hairline fracture right away. But again, with the heat cycling of the vent stack, that hairline fracture could become, a much bigger crack down the road, and you're not going to go notice that. You're not going to go inspect that, and then that could be a potential path for carbon monoxide to leak into the home or something like that. So,
almost certainly, for instance, that's done in the vertical right above the appliance. So you probably have a very high. You probably have the highest temperature that it's going to experience at that point that the whole vent system would experience. And you're right. I mean, I think there's a huge potential for thermal issues there.
So you're saying, Ted, test ports save lives, is what you're saying?
Yeah. I think they have the potential to save lives and certainly to do the job right.
So there's a test port on every NTI boiler on the exhaust port.
Right.
Perfect.
And to that point, IPEX makes a section of pipe or fitting that has that port built into it.
Yeah, I mean, these four kind of issues just highlight that it's not one issue with the uncertified product. There are a number of issues in one venting system that could potentially cause problems. When you have all of these issues in one system, you're not setting yourself up for success.
I have a question on your picture. Is that stainless steel? That's stainless steel, right? Am I seeing that correctly?
Yeah, I'm not sure actually.
Well, then number one, it's a big no-no. You should never use stainless steel on a condensing boiler, eat it up. So you should use plastic, CPVC or PVC. So they broke that rule. I like your test port. It's at the Walter Morris training facility. It's nice because you can slide the analyzer right in there. You have that little cone, it slides right in there. It's very nice.
Yeah, it's essentially a coupling with a threaded port, right?
Yeah, and then you can gauge your distance from where you need to be, because you need to be in the center of the pipe. But I like it. We use it all the time, Ted. So
great. Yeah, I have a picture of it coming up. So if anybody's not familiar with it, it's coming up. So yeah, those are some venting issues that we see. I'm sure everybody has seen their fair share and has their own stories. But so getting into UL 1738, what is it? So it's a standard for venting systems for gas burning appliances. It covers categories 2, 3, and 4. So these are your condensing appliances and your appliances that have a positive pressure fan. So a fan or a blower essentially. It's written by UL, so it's Underwriters Laboratory. They're well known standard. They write standards and they do testing, third-party testing. So well-known organization. Like I mentioned before, the standard covers both metallic and non-metallic materials. So PVC, CPVC, polypropylene, stainless steel, aluminum. And there's over 50 different material and system performance tests. We're not going to get into all of those now, but there's a number of them. The standard is not really new either. It's been around for quite a long time, but for many years, no one could produce a non-metallic material that actually passed. So it was just, no one could really do it up until a few years ago. Now you're starting to see more of that. I think mainly because of the blending technology and some of the blending technology with plastics. You kind of get there now. But for a while, it was only stainless steel and aluminum that were able to pass. So this is one test that I wanted to highlight. And it's test 36 in the standard. It's called the strength test for non-metallic vent systems. So what it does is you take an appliance and you have a venting system attached to it, assembled basically like you see in the picture here. So you have 1 meter of vertical pipe and then a 90-degree elbow, and then you go horizontally for about 9 or 10 feet with 6 couplings. Then you have a termination through a wall. So it's to simulate a short venting system. The appliance is cycled for 10 minutes on and then 15 minutes off, and it does that continuously for 12,000 cycles. So what this is supposed to simulate is the entire lifespan of the venting system. One of the issues that you see with plumbing products is, they may be able and may be fine for the first year or two, but what happens with the appliances turning on and off is what this standard is simulating is you have heat cycling and then you have heat aging. So these plastics that are not meant to be used in these applications, when you have this heat cycling of hot gas and then cooling and then hot gas and cooling, it causes the vent pipe to age much more quickly than it would otherwise. And you have premature failures. So rather than lasting, the design life, it fails much more quickly than it should. So that's a big reason why you see plumbing piping failing. So after the 12,000 cycles, the venting system is disassembled and there can be no evidence of cracking, condensate leakage at the joints, other damages. And then the pipe assembly is basically cut into test specimens and they do an elevated temperature test, a low temperature test, and subject it to a force test. So this is basically saying, after the entire lifespan of the system, is it still suitable for use? Because you don't want your venting system to last, and be on the verge of failure after, 10 or 15 years of your appliance there. You want it to be still, perfectly fine for use. So this is a good test. It's a difficult test, but I think it's kind of highlights the qualification that goes on with 1738. Looking at some marking requirements, there are specific marking requirements. If you're looking at certified product, every stick of pipe and every fitting has a carbon monoxide warning label, reminding the installers that there's a risk of fire or poisoning of carbon monoxide if it's improperly installed. You have your temperature rating on the pipe and on every fitting. This is something that the plumbing products don't have. Otherwise, it would say 140 for PVC. You have installation instructions, which we talked about. So this is a requirement of the standard, a step-by-step process for solvent cementing, methods of support, clearances, securing on through a roof, terminating through a wall, expansion and contraction. So all of these things are included in the installation guide. And then one more thing I wanted to highlight is there's no mixing of components, and this is again a requirement of the standard. And the reason for this is the system during certification is tested from pipe, with pipe fittings and your terminations and solvent cement from one manufacturer. So in the field, that's how the system needs to be in order to keep that certification. If you start mixing other manufacturers' pipe or fittings, then that's not how the system gains certifications, and it's no longer a certified system. That's something to note there.
So that's pipe fitting, and when you say joining methods, that's the cement, the glue, and
correct.
Correct.
Correct. So pipe fittings, solvent cement, primer if it's required, terminations. So all of that from one manufacturer.
All right.
In terms of U.S. adoption, we're seeing quite a few places move to require UL 1738, and then others are kind of giving incentives. Highlight a few of them. New York City only allows CPVC, polypropylene, or stainless steel UL 1738 products. Massachusetts requires board-approved products, so they need to be approved by the Mass Plumbing Board and certified to a venting standard, so that you can't use a CPVC potable water pipe that's certified or that's approved by the board for potable water. It has to be made to a venting standard specifically and approved specifically for venting. I mentioned Birmingham, Mobile, Auburn, Alabama. They require 1738 for special gas vents. And then there's other areas such as Albuquerque, where they have a bylaw that, or a code in their code requires that PVC of all kinds need to be painted when it's installed outdoors to protect it specifically from UV light. But when we spoke to them about 1738, explained the testing requirements, they actually allow UL 1738 PVC an exemption. So that saves installers quite a bit of time if they're using PVC outside. They don't have to paint the pipe. In other areas like Idaho, they have a 5 psi air test on all their flue gas venting systems. And because of the testing requirements, they've waived that requirement for flue gas venting products that are certified to UL 1738. So again, incentives, and I think there will be some more on the way. But this is the way the market's moving. So looking at some design considerations, if you are going to be installing a venting system, what material should be used? What should your vent size be? Maximum vent length allowed? What is the equivalent vent length of each fitting? So these things are still going to be decided by the appliance manufacturer. The materials, the vent size, your maximum vent length allowed, equivalent vent length. These are going to be decided once these design criteria are chosen. Then you would look for a certified product that meets these criteria. So just an example here on the top right, say the appliance allows both 2-inch and 3-inch venting to be used. 2-inch, your max length would be 65 feet, 3-inch would be 150, and then a 4-inch elbow would be equivalent to 3 feet of straight pipe. 90-degree would be equivalent to 6 feet. It's going to depend on the appliance, but typically this is roughly in the range. And then a concentric vent, as an example, would be equivalent to 20 feet of straight pipe. So if you're working with a new appliance, it's always something to double check. Make sure you're within those limits. Installation best practices. So appliance service time, this is very similar to a joint cure time. So when you're working with our system 1738, it's important that you let the joints cure before you ignite the appliance and have hot flue gas running through the appliance, through the venting system. So it's going to depend on temperature and it's going to depend on size. But for our size right now, from 2 to 4, it doesn't change on that size. But typically, as you get into larger piping systems, the cure time is longer. And as the temperature drops, it takes longer to cure. So anything above 60 degrees is going to be a 30-minute cure time. Between 40 and 60 degrees, it's going to be 2 hours. And then if you're installing, the temperature that you're actually installing the system at is going to be below 3 degrees, it's going to have a 12-hour cure time because it takes much longer for the joint to cure.
Matt, while you're talking about joint curing here, and I'm, with PVC, I'm assuming that your product, the 1738 product, uses standard PVC glue and solvent?
Nope. So part of the standard actually requires that the primer and the solvent comes from IPEX.
Okay, so is that primer and solvent, are the fumes combustible?
It's low VOC. So, I mean, possibly, I'm not exactly sure on that. It's essentially.
I would guarantee it's combustible.
It may be if you can concentrate enough.
So I'll just warn people.
I know where Steve's going with this. Yeah.
I would say that everybody on here, make sure that if you're gauging these times this close, that means that you're doing your PVC, your UL 1738 venting last. And I would say that while it's curing, unplug the low voltage line going to the blower and let the blower run and get rid of the product's combustion so you don't blow up the boiler, which we've seen now 3 times in 11 years. But it is an eye-opening, boy, it will shock the shit out of you when your boiler blows up in front of you. Make sure that gets there. Sorry, Matt, go ahead.
No
Yeah,
problem. I'd say,
and to that end, we always recommend that when you put the boiler on the wall, when you hang the boiler, the vent should be the first thing you do, not the last.
that's a good point. That's a good point. So yeah, these are something that are, it's important to pay attention to. They're in the installation guide. They're on our website. And just so we're clear, it's not it's the temperature at that when you're actually performing the solvent cementing. It's not will this piping system experience that temperature we've seen before. Question comes up: can you paint a certified system? And the answer is yes, as long as just as like you would paint any other PVC system, as long as the paint is compatible. Typically, we try to advise maybe don't paint over all of the markings, so that if anybody ever needs to go back and confirm something, maybe put down some masking tape so that it can be peeled back up afterwards. Nothing major, but it's always good practice to leave a few of the markings exposed. And then you have termination options. So we're starting to get into the actual system now from IPEX. So there are termination options. This is your concentric vent. Concentric vent is essentially allows you to have a single hole instead of a 2-hole termination. It can be used horizontally or vertically. It comes in 2-inch, 3-inch, and 4-inch sizes. So it accepts both your intake and your exhaust on the inside of the wall or the roof, and then converts it into a concentric pipe on the outside. So saves installers time, but make sure that the termination is approved with the appliance you're using. Low profile.
NTI does approve the concentric vent.
Yep. The termination options, the second one is going to be what we call a low profile termination. So this is essentially still a 2-hole termination. So you still need to make a penetration through the wall for both the exhaust and the intake. This can be used only horizontally, but it's essentially sits much more flush to the outside of the building. So the exhaust comes out through the middle port, and then the fresh air intake comes in through the gap around the outside of the cap there. And I believe NTI also approves these, I think in 2-inch and 3-inch.
Correct.
And then we actually have a new termination, which I thought would be good for, this might be a good audience. So what we call it is a universal concentric vent, and it's designed specifically for wall-mounted appliances. Right now, if you have a wall-mounted appliance and you want to terminate with a concentric vent, because of the Y that's on the inside of the wall, it's obvious it's not very easy to go from the appliance into that Y. You end up with a lot of excess fittings. Obviously, this looks terrible, but it's not very easy to go from the top of the appliance into that Y because of the just the geometry, really. So what we've done is essentially eliminate the issue on the left, and we've designed a kit that comes with your concentric vent, and it's a cap that sits on the top of the appliance that accepts your vertical piping and then converts it into a horizontal concentric vent. So it's a kit, and I'll explain it here. So this is essentially what it looks like. And I'll explain a couple reasons why we call it a universal concentric vent. The first one is that it'll accept standard out of the box 3-inch intake and exhaust. We have bushings that you can reduce down to 2-inch. So it can accept both 2-inch, the one kit will accept both 2-inch and 3-inch intake and exhaust. The screws that you see there, there's about, I think, 4 screws. If you, out of the box, it comes standard as a right-hand exhaust. So the right hand is the exhaust, the left hand is the fresh air intake. You can unscrew that and flip the unit to convert it to a left-hand exhaust, right-hand intake. And then the third reason is that different appliances have different center-to-center spacings between their intake and their exhaust. So this actually has on the green left there, it's basically a bracket that allows your fresh air intake to pivot back and forth, side to side. So it has a wide range of offsets or center-to-center spacings.
This is one of the coolest, newest venting products I have seen in 20 years of working with condensing boilers. This
piece
hot.
right here. Yeah.
I mean, now, understand, Matt, that I've been looking at the IPEX name on almost every single concentric vent I've sold that goes along with 6 or 7 different manufacturers' products. I pull them out of a bag and they all say IPEX. And I'm looking at this going, that is genius. I love you.
Yeah, we just launched it. We appreciate that. We just launched it, and yeah, with COVID and everything, we haven't really got the word out as much as I would like to. But yeah, it's a super cool product. We're excited about it. But that's essentially what it looks like once it's assembled, and it's a kit. So you have one part number with this entire everything you see on the screen here.
Is the horizontal, is that a fixed length, or can that be cut, or how does that work?
So yeah, it comes in the box. The hub that you see that accepts the vertical piping, and then there's 2 feet of concentric piping, and then you have your rain cap. It's not assembled in the box, so the 3 of them are separate. You can cut the 2 feet of piping down to whatever length you need.
I got you. Okay.
Yeah.
Nice. That's very, very convenient.
Yeah. No, we're hoping people like it. This is the access T or test port that we just talked about a few minutes ago. Really, it's a coupling with a threaded port. I think it's a 1/2-inch threaded port. Allows the combustion analysis test to be done quickly, safely, and then you can seal that back up. You don't have to worry about tape falling off or caulking falling off, or someone not realizing what that is and messing with it. So simple solution makes everybody's lives safer. So that's the presentation. I'm going to quickly go through our system for everybody that's not familiar with it. This is what the system looks like. It's called System 1738 PVC. This system, if you compare this system to a plumbing system, the dimensions are exactly the same. The pipe is Schedule 40 pipe. The fittings are the exact same dimensions. We actually also have this system certified to a plumbing standard because the dimensions are exactly the same. The difference between this system and a plumbing system is the PVC compound that we use to extrude the pipe and mold the fittings. We worked on it, I believe, for close to 7 or 8 years. Because it was very difficult to actually get this product to pass UL 1738 because of all the testing we talked about. So the system currently is available in 2-inch, 3-inch, and 4-inch pipe and fittings. The flue temperature is 149 degrees. So that is the flue temperature, and it's calculated based on the UL 1738 standard. So if you know an appliance is going to be using or producing temperatures above 149, we have a CPVC that is coming out, and we have another CPVC system currently available for higher temperature applications. It comes with a 10-year product warranty. So the system has, or the pipe has 2, sorry, I'll go back to this, looks a little bit better. The pipe has 2 orange print lines on opposite sides, so they're 180 degrees apart, so that regardless of how the system is installed, you'll always see one of the orange print lines. Same thing with the pipe, or same thing with the fitting hubs. The stickers are on opposite sides, so there's 2 stickers on every hub. You'll always be able to see one of the stickers. Once the system is installed, it's very clear what the system is. You won't mistake it. The temperature ratings are all over it. So there's no mistaking it. The carbon monoxide warning label, that sticker on the right, is on every stick of pipe. And the same thing is on the fittings. The primer and solvent cement. So again, they have to come from IPEX. The solvent cement is a 1-step solvent cement unless you're installing below freezing. So at the time of installation, when you are actually solvent welding the pipe and fittings, if it's above freezing, then you don't need the primer. If the jurisdiction requires it, then that's fine. It's not going to hurt the system to use it above freezing. But on our end, it's only required below freezing. So the primer is a yellow, fluorescent yellow that you see there. The solvent cement is the auburn orange color that matches the print line on the pipe. So there's 2 ways to identify if the right solvent cement was used. First, it'll match the print line on the pipe once it's cured. And the second is we put an optical brightener in it. So when you shine a black light on the cured solvent cement, it'll sparkle kind of like a glitter. That picture is a bit exaggerated, if I'm honest, but it's like a glitter. So, if anybody ever needs to go back and confirm the right solvent cement was used, there's a couple different ways: the color and the black light.
I'm sorry, Matt. I'm just trying to picture what houses would have a black light around their venting, and I'm sorry. I just went some strange places. So that's pretty cool that it's going to glow yellow.
You know, what happens is once the inspectors get hip to it, they have a little flashlight that does that, right?
So yeah, we've started handing out some flashlights at trade shows and when we meet with some inspectors, so they have it. If they remember to bring it with them is a different story, but they know about
Yeah.
it.
So it doesn't only have to. They don't. It doesn't only show up in nightclubs. In other words.
And then lastly, this is just to wrap it up. We have our system 1738 CPVC. So this is the same system in CPVC coming soon. So hopefully we'll have more news shortly on that. Once it's launched, it'll be the same system with a higher temperature rating. So 2-inch, 3-inch, and 4-inch. Same Schedule 40 pipe dimensions. The flue temperature, the rating will be 194 instead of 149. So it'll have the same 10-year product warranty. So yeah, we are excited for that. This is a product comparison of everything available on the market right now. So PVC, CPVC 149, 194, Polypro 230, and then anything above 230, you're going to be looking at metallics. Our systems are 2 to 4-inch, and then above 4-inch, if you still want thermoplastics, you're going to be looking at polypropylene. We do plan on expanding to 12-inch once the CPVC is launched. Support spacing, 5 feet standard. With the polypropylene, you do want more of I think it's 3 feet. And then the metallics are going to depend on what, the size range and everything like that. Solvent welding, we talked about. Appliance service time, there's no condensate considerations with PVC or CPVC. The only condensate consideration really is with the polypro. You want to make sure that, not with the material itself, but with the gasket, you want to make sure it's sloped back properly so you don't have that condensate sitting on the gaskets. Other than that, metallics, that's going to be your biggest drawback with corrosion. But that's it. Thank you, everybody. I'll open the floor if anybody has questions. We went a little long, so I apologize, but I'll leave it at that. Thank everybody for joining.
So Matt, I'm reviewing the questions. I don't see anything out there. Do you guys see anything out there that hasn't been asked yet?
Yeah, what's the cost difference between 1738 and standard PVC? You have a sense of that?
Not very much, if there's any at all. Now with everything that's happened in the last few years with PVC and the resin prices, and the reason for that is we blend this compound in-house, so we have more of a control over the additives. It's not so much of a generic blend. So yeah, I don't think there's much of a difference at all anymore.
So Matt, I have to ask you, there's some people out there that say they're ULs, I think it's 636C. And then there's, of course, this one, 1738, but what's the 636C? What is, I'm confused. Is there one? Is there two? Does, NFP 54, what are they doing?
Yeah, so the 636 standard is written by ULC, which is Underwriter Laboratory of Canada, and it's a similar standard. It's essentially the Canadian version of this standard. It's less stringent, so it was actually written into the National Building Code in Canada in 2007. So they require it across the country, and those products are definitely better than uncertified plumbing products. But when we were undergoing testing, we actually tested those products to 1738, and they still didn't pass. So those products are, again, better than plumbing products, but 1738 does give you the best products.
Cool. And of course, the question always comes up: can you use can you use 1738 for the exhaust and standard PVC for the intake? And can you use your cement so they don't carry two? Can they use your cement for 1738 on standard PVC?
Yeah, so you can use the fresh air intake. Does not have to be certified. You can if you want, but it doesn't need to be. And then on the solvent cement, our solvent cement will work with normal PVC. You might want to run it by the inspector to make sure you don't get into trouble there if he's okay with it. But as far as actually functioning, it'll do the job, no problem.
Cool. Very cool. So if they use the black light up against the PVC using your primer, they're going to have like iridescent joints on their PVC intakes too.
Yeah, exactly.
Cool.
So, exactly.
Very cool. Matt, thank you very much for an informative presentation. This is phenomenal. I'm looking at this guy using some sort of fancy PVC cutter here on the pipe, and he looks very serious. He's got this IPEX hard hat on. He's got his IPEX gloves on. He's got his IPEX jacket on. He's got his probably a IPEX PVC cutter with an extra long blade on his copper cutter there. That's amazing.
He's got his game face on.
It definitely has his game face on.
Yeah. So yeah, he's working hard. But
I like the
you don't have to
gloves.
use that cutter.
I like the gloves. I think the gloves are great.
Yeah, gloves are great.
Yeah, mechanics gloves with the logo on them.
All of our hands are bare right now, and I see these great IPEX gloves. Do they come in insulated?
I'm not sure. I don't have a pair either.
And there it is, folks. There's a set of IPEX gloves that nobody knows where you can get them from. So.
Anyway, so yeah, thank you, Matt. This was great. Very informative.
Yeah, no problem. No, thanks for having me. I appreciate it. It was great spending some time with you guys.
Yeah, we really appreciate you doing it.
So for those of you hanging out, I just have to say Matt's an old friend. I should have said this earlier. Matt's an old friend. We met almost now an hour and a half ago. And
we go back.
Yeah, way back. So.
Yeah.
Matt, great presentation. Extremely informative. I can't wait to see pricing and numbers on that new vent pipe, the concentric vent pipe you have.
Yep.
That's amazing. That's the first new thing I've seen for venting come out that I've really been excited about.
Yeah, we can send you guys some samples if you guys want to take a look at it. No problem.
Yeah, it's pretty cool. Pretty cool. So cool. Hey, you guys see any other questions out there? I'm sitting here looking at a single screen and I can't see everything at one time. But you guys see anything out there that needs to be asked to Matt?
Yeah, somebody asked if those numbers he printed on vent lengths and whatnot were specified, and I just want to make it clear that I think he was using excerpt from a particular manufacturer. In all cases, in terms of sizes and lengths, go by the manufacturer's install guide.
Yeah, 100%. That was just an example.
Yeah, exactly. Just so there's no confusion about that, because we definitely use different, let's say, pressure drop on an elbow. We say everything's 5 feet, for instance. We say on some of our smaller appliances, you can go 100 feet in 2 inch, 150 feet in 3 inch. And so I just want to be clear that, yeah, you can still do what we say you can do, but you can do it with this product.
Exactly.
So Matt, if we can stop staring at the guy with the 6 o'clock shadow, if you
we'll go to thank you.
Stop sharing your screen, everybody. Yeah, there it is. That's awesome. So
yeah, thank you. Wonderful.
Yeah.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.